Hello, this video is for the class Language of Algebra. If you're in this class, you know the drill. I'm about ready to throw up the answers and you can grade yourself. If you're not, then you can always go into the description if you would like to take this class and click on the link and it should bring you to my profile and you can choose the class the Language of Algebra. Alright, so give me a second and I'll put these answers up here. Alright, so here is your answer key. Go ahead and pause and grade yourself, and then we'll get to where I show you how to do this. Okay, so let me change my pen. I'm going to assume that you paused, and we'll get started. All right, so this first one is just evaluating. So everywhere I see P, I'm going to put -12. So 16 minus a -12. I want to put that in parentheses only so that these two negatives do not run together. But I got to evaluate this. When I have two negatives, same sign, okay, that's like multiplying a negative and a negative. Remember, double signs follow the rules of multiplication. So same signs, it turns into addition. All right, so then I add these two together, and I don't get 38. Sometimes I do this. 28. Yeah, that's what I've written down on my key. Sometimes I just write sloppy. All right, so now I'm going to evaluate it when t is -14. All right, so in the place of t, everywhere I see a t in my expression, I'm going to put a -14. So -14 minus 7. This is like I went to the store and I went to one store and I put $14 on my credit card. I go to another store, I put $7 on a credit card. I owe my credit card $21. All right, so everywhere I see an X, I'm putting a 4 in there. I have double signs going on. So different signs is negative. Remember, it follows the rules of multiplication. 13 minus 4 is 9, minus 2 more is 7. All right, we got to do the opposite operation. So the 19 is adding to the y. So the opposite operation would be to subtract. Okay, the opposite of adding is subtracting. So I'm going to do that to both sides. It's going to cancel out, leaving me just with y. 9 minus 19. I have $9. I spent 19 on a credit card. I still owe my credit card $10. All right, so in this one, the 4 is multiplying to z. So to get rid of it, I have to do the opposite, which is dividing. All right, so 4 goes into 32 8 times. Positive and a negative make a negative. All right, in this one, I can flip-flop. I can move the p minus 3 to one side and the 52 to the other. Still haven't changed any of their signs. The p is still positive, 3 is still negative, 53 is still positive. So the 3 is subtracting the p. So to undo it, I'm going to add 3 to both sides. That comes out as a 0. P equals 55. All right, 3 more of these and a word problem. All right. So in this one, the 11 is adding to the x. So the first step is I'm going to subtract it. Because that's going to give me a 0 here. And what I do to one side, rule of equality, got to be fair, do it to the other. That leaves me just with the 9x because that's going to go to 0. These two subtracted is 99. The 9 is multiplying the x, so I'm going to divide 9 on both sides to undo it. 9 goes into 99 11 times. All right, this one's a little tricky because the 8 comes first, okay? But remember, this 8 is a positive number, and what I'm trying to get is a 0. So if I add an 8, well, it would be 8 plus 8 minus 6x. That's not going to give me a 0. That's going to give me a 16. Okay, I need to get a 0. All right, so there's two ways I could look at this. I could first, and this is just a how you like to organize thing, okay? I could flip-flop. As long as I don't change the signs of things, I can rearrange. So like this 6x can go first as long as it remains negative. This 8 is positive, so it can go after. Then I see that what the 8 is actually doing is adding to the x. All right, and I could subtract it from both sides. That is going to leave me with 54. Okay, all right, and then the negative 6 is multiplying to the x, so I have to divide, leaving me with a negative 9. 6 goes into 54 9 times, negative, positive, ends up as a negative. But there is another way I could look at it if that's hard. If I have a hard time moving these around organization-wise. For me, my brain can't process it in this form, but some people can process it in this form. I don't want to change the way your brain looks at something because I want you to completely understand it. All right, so if you're looking at it this way, okay, then you have to say to yourself, to be able to get an x, if this is a positive 8, the way to get a 0 is subtracting it, right? 8 minus 8 is 0. Then I'm going to write the rest down. That's going to go to 0. If I take away 8 from this side, it's 54. So if you're looking at both sides, you can see I'm still going through the same steps. The only thing that's different is the way I organized it, okay? And that has a lot to do with comprehending a problem. People are going to internalize or organize things differently, and you have to have that ability to be able to do it the way your brain sees it, okay? So whichever way makes you feel more comfortable. Now, I don't like looking at it this way. My organizational brain likes to flip-flop it. You don't have to flip-flop it. I'm going to, okay? So the 4 is being subtracted, so I am going to go ahead and add it to both sides. That goes to 0. The 3 is dividing n, so I'm going to multiply on both sides to undo it. 18 times 3 is 54. All right, the word problem. So Acme Sports manufactures 3,216 tennis balls a day. Each container holds 3 balls. How many tennis balls? How many tennis ball containers are needed daily? So if I was using common sense, let's just ixnay what the answer is. And let's just say I broke this down into common sense. Well, common sense would say if I produce that many tennis balls, 3 goes into a container, then this is the answer, right? I would divide 3 into 3,216, and that would equal x. Now, I told you that equaling x, this is technically an equation, all right? But this is the proper way of writing that equation. With the total amount, the equation being equaling the total amount. Okay, that's a proper equation when it equals the total amount. All right, so the best way to get to there, if you're having trouble seeing that this is the equation right here, the best way is to just write out common sense and then opposite operation it. I know this is the total. I need to get it by itself. The 3 is dividing it. I'm going to multiply 3 on both sides. And then I have 3 times x, which is 3x. And I can either write it like this, or I can write it like I did over there. Okay? So if you're having trouble getting to this equation, to the answer, write out your common sense of what you would do to solve it, and then use opposite operation to get it into an equation. A proper equation always equals the total. All right? The total amount produced each day is 3,216. Our equation should equal that. And then we can do opposite operation. Divide both sides by 3, and you'll get 1,072. All right, that's it for this video. Keep practicing till you feel like you got it, and I'll see you in the next one.